Hi everyone, my name's Simon Prickett. I'm a Senior Curriculum Engineer with Redis Labs, and today we're going to take a look at a new command that was introduced with Redis 6.2. It's called GEOSEARCH. It's going to allow us to build a small railway station finder using a Flask backend, Redis of course, and the Leaflet mapping library for JavaScript. Let's get going. With me, Simon Prickett.
In the corner.
So to get going with this demo application, I've gone ahead and created a GitHub repo that we can see here. This contains everything we need to run the application. So there's source code, a Docker Compose file that will handle bringing up Redis 6.2 for us, and a data loader and some sample data in a KML file. So what I'm going to do now is go ahead and clone that to my machine locally here and just go through the setup process for it. So we'll do git clone, and we're cloning the repo, and then we've got a copy of it. We can go into there, and you'll see we have, amongst other things, a Docker Compose file and a requirements text file for our Python Flask backend. So first things first, I'm going to start the Redis instance. So I'm going to do Docker Compose up -d, have that in the background. And I just upgraded my Docker. So Docker Compose is now with the space in the newer version, but the old Docker -compose still works. And that may well be what you have at home. So we should now have a Redis instance running, and we can check that out with Redis CLI and do info server. Make sure we've got a 6.2 Redis server. There we go, 6.2.1. So that's perfect. That'll have the GeoSearch command that we need. I'll come out of that. And what we're going to do now is just set up the Python virtual environment for the backend. So I'm going to do Python 3 -m VM and create a virtual environment so we keep all our dependencies tidy and away from any other Python projects you might have. And I'm going to do activate that environment. So activated that, and now I need to install the dependencies into it. So I'm going to do that with pip install -r requirements.txt. And we're going to go away and install basically Flask and its dependencies, because that's what we're using here in this project. So we now have a backend up and running. The next thing to do is going to be load some sample data. So let's take a look at that. We've got a script here called loadstations.py, and we've got a file called stations.kml. And what my loadstations.py is going to do is load information about rail stations in the San Francisco area into a geoset or a geoindex in Redis. So let's just run that really quick. So Python load stations.py, and we've loaded all 52 stations. So now if I go into Redis CLI again, and we do this, don't do this in production, then we see we have one key called stations. And if we look at what type that key is, it's a Z set, which is a Redis sorted set. That's the data structure that geospatial indexes are stored in Redis. They don't have their own specific data structure. They just use the Z set, which sometimes is handy. So what we're going to do today is look at how to use a new command, GeoSearch, to make some queries against this set. But first, let's just quickly come out of here and open up our IDE. And take a look at how that data loader worked really quick. It's nothing particularly amazing. Let's make this a little bit bigger. And what we've got here is some code that uses a KML processing library. So KML is a format for geodata. You'll see that Google Earth, for example, supports it. I got these stations from the railway system provider's website in this format. So I was able to just take that file and we can use it here in this project. So what we're going to do is define a key for stations. We are basically going to start a connection to Redis here using Redis Py, the client for Python. I'm going to open my stations file and use that KML processor to read it. And then basically here, I'm just going to loop over every station that it found in the KML and get some properties of that. So we're going to then run the Redis geoadd command, which adds items to a sorted set and geohashes those. We're going to use the stations key that we had before, so that one key that we saw in Redis, and we are going to pass it information about the XY or long lat position of the station and the station's name. So that's what we're storing here, is we're storing station names against a latitude, longitude position. And when we're done, we're just going to see how many we loaded and then output that, which is, you saw I loaded 52 stations. We're doing this in a Redis pipeline. So we send all of these commands to Redis in one network round trip. So that saves like a 50 something round trips to the server for just inserting an individual station. We're going to do them all together. So that's the data loader. We're just going to use that the once. It's kind of a throwaway bit of code that got us to the start point. And the next thing we're going to look at is the backend Flask application. Okay, so now we've got our data loaded. We actually want to start that Flask app and see what it can do. So what I'm going to do now is switch back to terminal here and do Flask Run, which will start our application on port 5000. So let's go and have a look what we have there. I have localhost 5000, and we can see the application's front end here. So this is a web front end. It's being generated using the Leaflet mapping framework and Bulma for CSS, which makes styling things to look reasonably good out of the box very, very easy. So I'm a big fan of Bulma. It's great for building these sorts of demos. So the way this demo works is I can move around the map here and I can zoom in, and this is all stuff that Leaflet is doing for me. We don't really need to write code for this. And what I can do is, if I decide to click on the map somewhere, so I click here in South San Francisco, we've dropped a pin on the map there. That's going to be the location that I'm physically in. So I want to find train stations that are around me. Now, what you'll notice when I click that was we populated the latitude and longitude fields in the form up the top there. And this is the data that we're going to pass to Redis to make a geo query. So we have two sorts of query we can perform here. We have the radius query and the box query, which is something that is new in the GEOSEARCH command in Redis 6.2 that wasn't in previous versions of Redis. So in previous versions of Redis, you would use the georadius command to do the radius query, so circular radius of this point. And now in 6.2, you can use the new GEOSEARCH command for both the radius, the old functionality, and the box, the new one. So in 6.2, the georadius command is considered deprecated, and you should use GEOSEARCH in new code. So for the minute, let's just stick with a radius search, and we'll say we want to do a radius of like 5 miles. This is hard coded to miles in this interface, but Redis supports kilometers, meters, etc. And these are grayed out because they relate to the box search. So if I hit search, what we've done there is we've made a call to the Flask application in the back end. It's gone and talked to Redis and say, hey, Redis, can you do a GeoSearch for stations within a 5-mile radius? We've got those back from Redis. We've turned them into an array of JSON objects, pass them back to our front end, and it's rendered them. So I can then zoom in on this and we can see what we got here. And if I hold the mouse over here, you should see South San Francisco. That's the station name. Next one up the line is Colma, and so on. So this is all functionality we could have done in previous versions of Redis. And let's just select somewhere else on the map. I don't know. Let's go for here, Daly City. What we need the new 6.2 GeoSearch command to do for us that's new and different is this box query. So instead of doing a circular radius from the point that I've clicked on, we can do a box. And sometimes that's advantageous. And I've picked this geography specifically for this reason. So if I did a radius here and I did like a 10-mile radius, nope, not quite far enough. So if I did a 15-mile radius, there we go. Then what we see is from my position, there are stations in a 15-mile radius that are both on my side of the peninsula. I'm on the Silicon Valley side, and also on the Oakland side of the peninsula. And those aren't necessarily easy for me to get to because I'd have to cross a bridge or they're a lot more difficult to get to than ones that I could just drive or walk to. So in some cases, a radius search isn't necessarily what you want. So we're going to change this and try a box search, and we're going to do a box height of, let's say 15 miles, and a box width of, let's say 8 miles, and we'll see what that gives us. So now using the new Redis 6.2 GEOSEARCH command, I've been able to define this box, and my location is the center of the box essentially. And we can now search for stations that are just inside that box. So what we've done now is we're able to basically get rid of all of those ones on the Oakland side of the bay, because those aren't that relevant to me. I can't get over there easily. I'd have to take a ferry or cross a bridge or pay a toll or all of those things. So the GeoSearch command supports both radius searches, circular radius, and this new box method. And that's what's allowed us to do this. So next thing we should do is go take a look at the Flask application behind this, see how that application is talking to Redis, see what commands it's running, and see what data comes back. So let's start to look at how this works under the hood. Back to Visual Studio Code here, and I'll just get rid of the data loader that I had open. Our backend application for this is a Flask application. Flask is a framework that allows us to associate functions with different HTTP routes and verbs, and basically have the browser request things from the server, and when a certain route is hit, the corresponding function is run, and we can return whatever we like. So here we have app.py contains our entire Flask application. There's some preamble here for setting up Flask. And we're making a connection to Redis, because obviously we're going to do some queries in Redis to get the matching stations back. And we have 3 routes in Flask here. So really simple one, I have the / route. So when I went to localhost 5000, it served the home page. We're using Flask template system there that's built in, and it's going to render an HTML file that contains the Bulma CSS that we're using, the JavaScript for Leaflet, and the JavaScript for our application, and we'll look at how those work later. We then have these 2 routes here, so search by radius. This function is associated with this URL, and that's a GET request. And then we have similarly search by box, and that is associated with a slightly different format URL. And these are the 2 entry points that the front end is going to use to talk to the back end, get data out of Redis, and present it back as an array of JSON objects. So how this works is they're both very, very simple. Search by radius takes the latitude, longitude, radius, and the radius unit, which I hard-coded into the front end as miles. So you can see what that URL would look like here. It's localhost 5000 /API /search /by radius, and then the lat long that we're looking for, the radius that we want to search for, and the radius unit, which is miles in this case. And the way that this works is we then call the Redis GeoSearch command. We pass in the name of the key containing the geospatial index. So we called that stations when we loaded the data. And GeoSearch has a couple of forms. So the first one is we're going to say we're searching from a latitude, longitude, and we're searching by radius. And then we're going to pass in the radius and the radius unit. And we're going to pass in this modifier with coord, which tells GeoSearch that when we call it, we want it to return not only the matching station names, but also the coordinates. And we need those so we can plot them on our front end map. If we didn't need those, we could omit that and we'd be sending less data back from Redis. But in this case, we want those because we're going to draw a map. And similarly, when I do the box search, we have slightly different parameters. We have a box width and a box height and a box unit, which again is miles in our case. So the URL looks a bit like this. So we're passing in the lat long, a width of 5, a height of 10, and miles as the unit. And then again, we're going to call the GeoSearch command. We're going to pass in the stations key, so the sorted set or geo index that we're searching. Again, we want to search from a longitude latitude position. And we're going to do it this time rather than by radius, by box. So this is new functionality in Redis 6.2, and obviously both of these calls to GeoSearch are new syntax because the GeoSearch command is new. So we've got the box width, box height, and box unit, and again that with coord modifier. So we want to get the coordinates back again so we can plot them on a map. So what happens when we run this is that's going to happen, and then we'll get a result back from Redis, and that will be basically a list of stations with their latitude, longitude. And we just have some code here that's going to transform that into Python dicts and then onwards to a JSON array of objects. That's a utility function that you can check out yourself in the code. It's up the top there. So what I wanted to do was show how this works in the back end so you can see what the Redis commands look like. And I'm going to take this query here and we are going to copy that into the clipboard, and we're going to do a couple of things. So first off, I'm going to leave the Flask application running, and I'm going to create a new tab here and connect to our Redis instance. I'm going to run the monitor command. So this is going to look at every command that's going into that Redis instance, and it's going to echo it back out for us. So when I cause the Flask application to do something, it's going to talk to Redis, Monitor is going to show us that, and Redis is going to send the results back to Flask and render them. So let's take a look at just the Flask application without the maps front end. So if I start a third tab here, make this a little bit smaller so we can see Monitor over here. And then I paste in my URL from the code. So we're hitting the back end here. What you'll see is I've got an array of objects come back that describe each station. So the object's got a location object that in turn has a latitude, longitude, and then a station name. And we've got one of those for each station that matched. And over here in Monitor, you can see the command that we ran here. So we ran GeoSearch stations from lonlat, these positions by box, 5, 10 miles, and with coordinates. So what you can see here is the command that our application sent to Redis. What we got back from that was a set of results, and we turn those into this list of JSON objects. From there on in, the front end goes and renders these using Leaflet, and we'll check that out next. Now we can take a look at how the front end works, and that kind of starts here in the back end with the Python. So we have a singular Flask route here that just serves the home page. So whenever I go to localhost 5000, this is going to happen. And what that's doing is it's telling Flask render a template called homepage.html. That's here in the templates folder. So I have a file homepage.html, and we'll go up to the top here. Very simple single page template. So we've got the entire HTML document in here. I'm pulling in the Leaflet library, and I'm pulling in the Bulmer CSS for my styling. Both of those do a lot of heavy lifting for us and save me having to write things that would overcomplicate this demo. Then the body of my document has two main sections. There's a form, which is where we build up the search query, partly by clicking on the map and partly by typing items into the form. And then we have the map itself. And the way Leaflet works is it attaches itself to a given ID in the DOM. So I've given it a div here, and that div's given some size properties in CSS. And then Leaflet attaches to that and renders inside there. It's going to deal with moving around the map and all of that stuff, and it's going to raise events when clicks and other things happen, and we'll write handlers to cope with those. So the majority of the application is actually, of course, in its JavaScript. So we have a app.js here. This is all code that I've had to write to make this application work. And we'll just take a look at what happens with some key interactions. So if we look at, actually, let's look at this really quickly. So we start by defining a map and say, I want to start in a given position. So that's what centers the map on the Bay Area. I'm using the OpenStreetMap tiles for this, which are free and open source, so we don't need to use license keys. And I'm basically setting that up and adding it to my map, which is a Leaflet map object that is going to live at that div that we gave it in the HTML, the one with the map ID. Then this is a Leaflet event handler. So when someone clicks on the map, we're going to run this code. And what we're going to say we're going to do is remove stuff that was on the map already. So any previous search results, markers, etc., radius circles. We're going to drop a marker and we're going to remember where that marker is and set its lat long value in the form. So what you'll see when I go to the front end here is, let's just open this out. As I click around here, you'll see the lat long populates in the form and it's following the marker that I'm dropping. So that's what we're doing there. We have some code that deals with making sure that only the right sort of search type fields are available. So for a radius search, the radius, and for a box search, the other two, the height and the width. And skip over that for now. And the majority of the work for this application is done here in the onClick function for that search button on the form. So when someone clicks the button there, this is everything that needs to happen. So just as a quick reminder, we'll do a radius search here. So if I do a 10-mile radius search and click this, what's going to happen is go off to Redis, get the results. We're going to plot the radius on the map so that people can see the extent of the search that they did. And then we're going to plot each one of the resulting stations, if there are any, on the map too. So code for that is basically, we'll get some information out of the form. We'll get a latitude and a longitude that we're going to need for both types of search. And we'll look for a radius. If we had a radius, then we're doing a radius search. So to draw the radius on the map, we need to convert the radius, which is in miles, to meters, because that's how the Leaflet API works. Utility function here does that for us. And then we just draw a circle on the map of appropriate size and appropriate lat long center, which is what you saw when I click search. Then we go away and talk to the backend here. So we're using one of those two Python functions that we looked at in the previous file in app.py. And this is the radius one. So we're going to go do that. And as we saw when we looked at it in the browser and with Redis Monitor, it's going to query Redis, return the results, and then we get a JSON array back. And then for each of those, we just run a map over a function called add station marker. And that is going to do the station markers for us. So in the same way that we put the marker on when the user clicked on the map, we're going to add a different marker for the stations. So you can look at that if you're interested in how it works. If we didn't get a radius and we got a box, we do exactly the same thing, except we have to do a little bit of map math here to draw the box on the map. We have to work out a sort of top left and a bottom right corner for the box, and then draw rectangles for that and figure out the size of them. That's all sort of Leaflet map stuff. It's not Redis specific. Again, the Redis stuff is here where we call the backend. We do a by box search for a lat long, width, height, and specify that those are in miles. We get our stations back. And again, same thing. We map the resulting array of station objects through the add station marker function. And that adds each of those stations onto the map for us. And that's really it. So let's just run through this again really quickly. So I can click on this and I can do, for example, a box search. And I can say I want to do a height of, let's say this time 5 miles and a width of, say, 20 miles. And we'll have something that looks a little bit different. We've gone out into the sea there both ways. But you can see all the stations that we've got are within our box. Today we looked at the GEOSEARCH command, which is new in Redis 6.2. It enables us to do radius searches like the old GeoRadius command did, and adds new functionality to search within a bounding box. If you'd like to perform these searches and store the results of them on the Redis server as a new key, check out the GeoSearch store command that can do that for you. If you're interested in learning more about Redis and Redis Geo, then check out Redis University, our course Introduction to Redis Data Structures, as well as our 3 programming courses for Java, Node.js, JavaScript, and Python developers, all cover geo functions. If you'd like to chat with us, then come join us at discord.gg/Redis, where we maintain a lively community. Thanks very much for coming along today. See you in the next one.